Hello and welcome to your introduction to Microscopes Lab. I am your teacher, Vanessa. I think you know this by now. All right, so before you come to class to do this lab, you should have already read your lab safety. In your lab safety requirements, there is a directions for microscope use. And the big deal about the directions for the microscope use is don't break the microscopes. And so we will briefly go over that when we get here, so that way you can actually get a chance to see it, actually get a chance to see the actual lens paper that you use to clean all of the glass on the microscope, versus you never use the chem wipes on any glass parts of the microscope. That is a huge piece. So we will go over that again. That way I can actually show you hands-on. And so today we're going to go ahead and go over our introduction to microscopes. And so I am looking at your pre-lab. I understand all these pre-labs say do pre-lab quizzes. I'm not going to take that off. There are no pre-lab quizzes during the summertime, okay? I'm not going to go and edit all of those documents just to remove that. Just want to throw that out there. Alrighty, so safety note. Great care when using the microscopes. So the big thing is do not drag your microscope, okay? Anytime you make any movements, you need to lift and rotate and set down ever so softly. You notice you have a handle here on the back. You grab it from the base and you always keep it close to your body. You never just willy-nilly pick it up, hold it this way, grab it this way. Never grab it by any other parts other than the base and the handle. Alrighty, so some of that is in your microscope usage. So whenever you pull out your microscope, I'm going to go ahead and scoot it over, that way you can see me a little bit. First thing you do, unwind the cord. As you can see, it is in the back. You're going to push this in to make sure it is all the way in, plug it in, turn it on with your side button. You have a little side button here, and when you turn it on, you should see light illumination. If you don't see light illumination, one of two things is wrong. The cord is not pushed in all the way through the back. That's one of the things that could be going wrong. The other thing is when you have the plug, all of these plugs have a safety on them. So which means somebody might have hit the trip button and hit test. You need to make sure to go ahead and push in that reset button. Okay, so after that, it should always go ahead and illuminate the light. If you've done those two things and it doesn't, call me over and we will go ahead and troubleshoot. Okay, so here's your microscope. Looking through your first page, read about the purpose to become familiar with all the parts and such, learn how to use it. This is what you call a compound light microscope. The reason why it is a compound light microscope is because it has, let's talk about the compound piece first. These are oculars. Okay, we're going to go over the anatomy of the microscope in just a moment. But with that, when you look through them and only them, it's almost like looking through binoculars. And so when you look through binoculars, it has a magnification. And so when you look through these, you're also going to be looking through these objectives. And you notice these objectives rotate just like such. And so we're never going to use that last one. I'm going to go ahead and back it up to the smallest objective. So each of these objectives have their own magnification. So like for example, this smallest one that says 4 times on it, if you look at it, it'll say 4x, and it's also the one with the red line around it. That is 4 times your natural vision. The oculars are 10 times your natural vision. So when you look through the ocular and you look through this objective, you're looking at 10 times, you're looking at 4 times. So 10 times 4 is 40. So you're looking at 4 times your natural vision. And so each of these oculars has a different magnification on it. But that's where that compound piece comes from. You're compounding the magnification. The light part, being this is a compound light microscope, you can see underneath light is going to shone. So when you put a sample on the slide, and that sample is going to have a specimen, when you put it on this slide, the light is going to show through it. So that is a light piece. It's going to illuminate through it, and that is going to help to see parts of your slide better. So that is your compound light microscope. So with the dissecting microscope isn't really my priority in this class, but it is still important because you will get to use that in A&P. We will also get to use that in Bio 112. So we will pull out the dissecting microscope. It's also called stereoscope. Get a chance to play around with it just to get familiar with it. And so that's going to be my objectives for those. So as we go through the anatomy of the microscope, go ahead and turn to page 2. Page 2 is going to just tell you all of the different parts of the microscope. We already talked about this. This is the ocular, also called the eyepiece. So this has its own set of magnification. It's held together by the head. I'm not going to go through everything on that list. So your nose piece is what holds your objectives, and you have several objectives of different magnifications. We will never use, in this class, we will never use the highest one. And the highest one, it's got the black ring on it most of the time. Some of them you might see a white ring, but this one has a black, actually this one has a black and a white ring. And so this is 100 times. So we will not use this in this class. I've had people ask me, Mrs. Aragon, I could see so much better on it. And I'm going to tell you, how do you know I told you not to use it? Okay. All right. So let me tell you why. The reason why is what this is it's for oil immersion. So you use it in microbiology. So which means you have your slides, and your slides have cover slips. And this is a perfect example of a very thick cover slip. So when you're using oil immersion, that is in microbiology, and you're not using a cover slip. That cover slip takes a lot of space up. It really does. So when you're on this highest objective, being oil immersion, what happens is that that the glass lenses from them could scratch along this glass. And the other thing is it could actually punch through the glass. So it could really damage the glass parts of this objective. So you are not to even try to use it. All right, so this is so I'm gonna go ahead and turn it back to the smallest objective. This is your stage. We can go ahead and grab your slide. You open up your stage clip, just like such. There you go. So notice how it hugged it. It hugged around the slide. So if my box is a slide and my hands are stage clips, it hugs around it. So there's some old-timey microscopes that you may have used in the past that what they do is they actually put the stage clips on top of the slide. You're not going to do that here. You can end up loosening the parts and damaging the parts of the stage clip. So you're going to place the slide within it, and what it's going to do is when you are moving it around using your knobs on the side, it's going to move the slide forward and back. It's going to move the slide side to side, and that's why you want to hug it. Also, make sure that your slide is pushed all the way back. Okay, hug it around, push it all the way back. Now, I could go ahead and use my stage control knobs. My top one is moving it forward and back. Okay, my bottom one is going to move it side to side. And that's how you are going to manipulate your slide so you can view your specimen. The next piece is going to be you have them on both sides. You have one on this side, you have one on this side. I'm going to go ahead and rotate it this way so you can see. You have yourself a large adjustment, coarse adjustment knob is the large one. And then you have yourself a fine adjustment knob, which is the small one. The coarse adjustment knob is going to move the stage in large amounts up and down, okay? So always, this is huge, always make sure when using the coarse adjustment knob that you are on this red one. It's called a scanning objective. So the one that's 4X is the scanning objective. And so I want you to watch. Notice how when I use the large knob, it is going to move the stage in large increments up and down, just like such. So if you were on one of these other objectives, or not that one, on one of these other objectives, it would punch through the slide, and we don't want that. So I'm going to go ahead and move it all the way down. The small one is for fine adjustment. So literally, it's like when you go to the eye doctor, and then they do some adjustments, and they say, this one or this one. And then they move it and they go this one or this one. That's literally what is going on with the fine coarse adjustment. It is adjusting to your own personal vision. And since I've mentioned that, your own personal vision, I realized that some of us wear glasses and some of us have different prescriptions than others. I've had people tell me in the past, my prescription is really powerful and I won't be able to see. And my challenge to them is, If this is times 10 and this is times 4 and this is 40 looking together, is your prescription 40 times the natural vision? I don't think so. So trust me, this microscope is going to make up for any prescription that you have. It's not going to make up for any like right-left abnormalities and stuff like that. So, but I say don't wear your glasses. I've been saying it for years, don't wear your glasses, because then what's going to happen, you're going to have to try to adjust through glass, then you're going to have to try to adjust through these lenses. And if you're looking for a headache, that's probably one good way to make that happen. All right, so then the next thing, as you notice the power switch. Power switch is right here on the side. Different microscopes, all of these microscopes in this room should be the same, but sometimes it's off to the back, sometimes it's a little roller on the side. It really just depends on the microscope. So here's your power switch right there, and we are powered on. The other thing is, we're gonna go ahead, we have our brightness adjuster, which is going to be right here. It's a little wheel on the side. So some microscopes that might start the power. It really just depends. So it's going to go ahead and allow more light or less light intensity. So up underneath the slide, up underneath the stage, you're gonna find the condenser. And the condenser is gonna be controlled by the diaphragm. And what that's gonna do is it's going to control the amount of light that is, the intensity of light that is let in. The side shows how much light, and then this one can actually fine tune the intensity of that light. And so when you are using your microscope and you see you are on 4x, with these fancy microscopes, you need to match that down here. On these, there's a wheel. It says 4x, 10x, 20x, 40x, 100x. So when you are on 4x, make sure your wheel is on 4x. And then when you turn to the 10x, you have to come down here and change the diaphragm to 10x, okay? So I'm gonna go ahead and go back to that 4x because that's where we always start. Okay, I think that's all I really need to cover. We got the meat and the potatoes of it. Dissecting microscope, you can go ahead and read about that on your own and read the parts on your own. So on page 4, there is basically a checklist of how to view a specimen on a slide. It's a very good checklist. It looks like a lot. I'm just going to go ahead and I'm not going to sit there and read the checklist. I'm just going to go ahead and speak how to do it. Okay. So first thing that you do, I'm going to go ahead and turn it off to the side. Actually, let's turn it off to the other side because I'm right-handed. There you go. That way you guys can see. So first thing to do, before you do anything, lower your stage all the way down, and it was all the way down. Then you take your specimen, your specimen is on the slide, and there should be a cover slip. Make sure anything you do in this class has a cover slip either already on it because these come from the factory, or if you are making a slide yourself, which we're really not going to be doing that too much in this class, but just in case we get to, you always have a cover slip. So slide it back, all the way back, put the stage arm around it. Now we can go ahead. So the first thing I say, turn down the light, turn it down. Our first instinct is turn the light up so I can see. Oh no, it's the other way around. Turn the light down so you can see, because if you have too much light illuminating, it's gonna wash out your specimen. So I have the light adjustment wheel on my left side, okay? So then I'm going to use my knobs to move the stage right, left, forward, back. And you want to make sure that your specimen is in the middle of the slide. And you're like, well, how will I know? Usually if you pick up the slide, you can see some type of green speck or pink speck or purple speck or even a black speck, because all of the ones that come from the factory, they are dyed, okay? They have contrast to them. So, alrighty, so you put it smack dab in the middle. The next thing with your oculars, you notice my oculars move in and out, okay? They move in and out. So some people have wider set eyes, some people have more narrow set eyes. you're going to adjust the oculars for your eyes. So what that means is when you're first looking at it, you're going to see two circles like this, okay? And then you're going to adjust this in or out, adjust, 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 where those two circles are going to meld and you're going to see one circle. Both of your eyes are open. None of this, okay? You always have two eyes open. So rotate your oculars in or out until you see one melded circle, just like such. Now, don't put your eyes on it, okay? We want to make sure to keep it clean anyway. But your eyelashes, if you see your eyelashes get in the way, you need to pull back just a little bit. And so just go ahead and meld it so you can see the circle. Now you may see a couple of things in there. You may see a pointer. The pointer is just a tool for orientation. Don't let it mess you up. And in some of these, you might see a little ruler, an ocular ruler, okay? We're not going to use the ocular ruler for this lab, okay? And so because, and the reason why is not all of the microscopes have an ocular ruler. So we're not going to do that part that asks for an ocular ruler. All right, so we're all ready. So the next thing is, so your eyepiece are adjusted, you are on the scanning objective, which is 4X. You have your stage all the way down and you have your slide set in the middle to look at your specimen. Now we're going to use the large coarse adjustment knob to lift the stage up so you start seeing the specimen. Now, here's the deal. If you see this, I have people like, wow, that is beautiful. It looks like space, the final frontier. I tell them, keep going. What you're looking at is glass. You're looking at the glass cover slip. You need to keep going so you can get through that glass so you can actually see your specimen. So that's not it. So let's go ahead and do that. I'm gonna go ahead and take it up, take it up, take it up. Now, always be looking through here. Never move this when you're looking away because you might miss it. I know these sound like obvious things, but they're common. Moving it, moving it, moving it. Oh, wow, isn't that beautiful? We got some spirogyra that I'm looking at. All right, so right there in green, I can see it. I can see all of the organisms. Now, I'm gonna adjust it for my vision, okay? So I'm gonna use the fine-tune adjustment to adjust to make it nice and crisp and clear for my vision. A little bit forward, back, and once it is at its clearest, then you can rotate to the next objective, which would be low power, okay? Low power objective. Never touch the large knob again. You will only touch the fine-tune knob. Only do the large knob when on the scanning objective, not on the other ones. So go ahead and look in there, use your fine-tune just to go ahead and fine-tune it to your vision. And what you're gonna find is, as you fine-tune it, depending on your specimen, you're gonna find some of them very clear and some of them a little fuzzy. And then as you kind of go back forward, those fuzzy ones will become clear, and then the ones that were clear will become fuzzy. The reason why is we are looking at a 3D sample, okay? We're not looking at a 2D sample, we're looking at 3D, so you can actually look through the specimen and behind the specimen and in front of it. So that's what you're looking at. Okay, so if you want to go ahead and get even more magnification, go ahead and rotate and it'll slide right in. Boom. You might be like, oh my gosh, it's not gonna go in. But if you can see it clear on the last one, you're good. You're good to just go ahead and slide into the high power. Now only, oh yeah, you got me. I should have been changing this every time, huh? There you go. Last one was pretty clear. I had a sample that was pretty clear. Now you only use the fine-tune adjustment. Boom. And you don't have to be exactly on, because I'm on 40, and it doesn't have to be exactly on the 40. Suggestion. But I want to add a little more light to mine, so I'm going to adjust a little more light in. There we go. Now I could take out a little bit more light just to see more contrast. There we go. Very nice. So that is how you look at your specimen. Now, my advice to you, if you say go from one to the next, and you're like, I can't find it. Okay, one of two things happened. Say I'm on my scanning objective, and I can see it, and it's great. And I go ahead and I rotate to my next one, and I can't see it anymore. Well, what I would say is back it up, go back to your scanning objective. Make sure your specimen is in the center of the circle. Then go ahead and change it. Okay, so that's the one thing. If it's off to the side, when you rotate and zoom in, you end up zooming into an area where the specimen is not. And so, alrighty, so the fact that I can go ahead and go from one objective to another objective and only use the focus, the fine-tuned focus, because it's already in partial focus, that is a term called parfocal. And you will see that on your page, P-A-R-F-O-C-A-L, parfocal. That just means it's always partially in focus. Next. So you are going to be doing page 5. It talks about the working distance from the microscope. You've already witnessed it when it comes to the amount of distance on scanning objective versus the amount of distance on low power versus the amount of distance on high power. Okay, so I'll let you guys work through that. It's pretty self-explanatory. The next thing is filling in the chart, table 1, total magnification for the compound light microscope. You scoot this over so you guys can see. Here we go. So your table 1, objective lens name. So we have scanning. We got low power, and we got high power. Okay. We also have that big one called oil immersion. I actually took that off the chart because we're not going to use it in this class. So I'm just letting you know that that biggest one is called oil immersion. So now that I'll take it off the board. Alrighty, so your first, objective lens name is the first column, and then the objective lens. They want to know what's the magnification. So magnification of the objective lens, the scanning is 4x. If you look at low is 10x. If you look at high is, I want you to actually look at it. Don't just put it up here because I put it up there. High is 40x, okay? Next column is ocular lens, the ocular objective. And the ocular objective is 10, 10, 10, okay? So the total magnification, 4 times 10, 40 total mag, boom. Okay, you can fill in the rest. Alrighty, so I'm actually, since I have this up, I am going to jump to page 7. Okay, so jumping to page 7, we are going to measure the fielded diameter of our circle that we can see in the microscope. So when we're talking about the fielded diameter, so I can go over here. When you're looking in the microscope, you see a circle, an illuminated circle, okay? We want to measure the diameter from one side to the other of that circle. And what that, we are basically figuring out how much in millimeters, and we can even convert that over into micrometers, can we see? And so when you look at this, we know that scanning, C-A-N-N-I-N-G, scanning is going to be 4, okay? I'm gonna go ahead and put the total down here. Total's 40. Okay, I'm working with the total. And so scanning is, the total is gonna be 40, and that is the magnification. Magnification equals 40. So now we want to figure out the field of view for that. FOV equals field of view. So in order to do that, you're going to need to put a ruler on your microscope. Remove any slides. You want to make sure that it is on the scanning objective. Take your clear ruler. Make sure you are using the metric side and not the inches side. So not the empirical side, but the metric side. So when you look at it, you have 1 centimeter, 2 centimeters, 3 centimeters, and so forth. You're going to just set it on top. It doesn't have to start at 1. I like to just set it where it makes sense, where I can go ahead and have it even and not wobbling around. I'm going to rotate so you can see. So you want to put it on the metric side, smack dab in the middle of the diameter of the circle. Look into your microscope, and then you're going to scoot the ruler over. That way you have one of the lines completely off to one edge of the circle, okay? From there, I want you to count how many millimeters are there, okay? How many millimeters are there? And you can convert it to centimeters. That's all good, because later on you're going to have to convert it to centimeters in order to figure out the area of the circle. So I'm counting this, 1, 2, I'm not going to tell you. I'm going to just make up a number over here. I'm going to pretend that my field of view diameter, when I put the ruler on it, let's go ahead and put ourselves a ruler on it. I'm showing you what I would see in the microscope. I got a line here, put that line there. 1, 2, 3, 4, and then say the other one was over here. Okay? So I got 1 centimeter, 2 centimeters, millimeters. Well, actually, let me see, my thing. Yeah, millimeters. Yeah. 1, 2, 3, 4, and probably like a half. So I'm gonna go ahead and call it 4 points. Let me see. I just want to make sure I give you a good number. 7. Wow. Look at that. I'm going to go ahead and throw another one on here. I just want it to be realistic. There we go. Call it. So 1, 2, 3, 4, and 5. Just to be realistic with your thing. So 5 millimeters is what I see when I look at that ruler. So that's your field of view diameter for the circle when you're looking on magnification of 40. So what's going to happen when you rotate and you zoom in? You might be able to see a couple of lines, but the problem is when you take the line all the way to the edge, it really depends, you may or may not be able to see black lines on the edge, or you might see a bunch of space. So at that point, it's guesswork. So since it becomes guesswork and unpredictable because different microscopes are going to give you different readings, because of that, you're going to have to calculate, okay? So the only time you measure is for the scanning objective. After that, you're done with that, okay? Then you're going to calculate. So in order to calculate, this is going to be the one on low power. And low power, I'll just go ahead and give it to you. 10 times 10, 100. Boom. Magnification equals 100. 100 times. Alrighty, so we need to figure out the field of view when it is on low. Boom, equals. This is field of view when it is on scan. Alright, so now that you have that, I'm going to erase it. Use the space. This seems to be the most confusing for students, mainly because of the calculation, but it doesn't have to be. So go ahead and look at the top of page 7, and you see it says M1 FOV1 equals M2 times FOV2. I like to actually write it in. I like to say magnification on scan times field of view on scan equals magnification on low times field of view on low. All right, you have 3 of the 4 variables. You just need to solve. So get rid of that x. Magnification on scan is 40. Field of view on scan, 5 millimeters. Equals magnification on low is 100. Remember, I decided to use the totals. Usually it just comes out the same, but just have it. Equals field of view on low. That's it. Solve for field of view on low. That's all you need to do. I'm not going to do the math for you. We've gone over math before. This is an algebraic equation that I'm going to let you solve. So your next thing that you do, once you solve for your field of view on low, go ahead and put that number here. Then all you have to do is change this to high, change this to the high magnification. I didn't finish the chart for you, but I think you probably have figured out by this point it's 400. And by doing that, you will have solved for the field of view on high. Just go ahead and fill out your table, which should be table 2. Yep, table 2. Alrighty, so then that's your field of view in millimeters. Use your area calculation for the area of a circle. You can also see that on the middle of page 7. Area equals pi r squared. Well, you have the diameters. Radius is half of that. Plug in your equations. So next, answer those questions that follow. So I'm going to go ahead and back it up to the letter E. Remember, we skipped. So viewing the letter E is going to be on page 6. And you don't have to do it on a piece of paper. You may have done this in the past where you had to draw the tiniest letter E ever. They actually have slides like that that have the letter E. Just need to find them. There we go. Here's your letter E. Make sure you put the slide in facing you, however it is labeled, okay? And then I want you to look at it through the microscope, adjust for the clarity as you need to, as I've shown you, and answer the questions on what is going on with the letter E. As it moves forward, as you move the microscope stage forward, what's the E going when you're looking through the ocular? As you move it back, where is the E going? As you move it side, which way is it going? When you're really moving it to this side, which way is it going? And vice versa. So you just answer those questions. So your next thing that you are going to do is on page 8. That is the depth of field. Remember, I told you that you're looking at a 3D specimen. So being that you are looking at a 3D specimen, we want to know the field, we want to know the depth. We want to basically we're going to illustrate the depth using the thread slide. And so all of your boxes should have a slide with threads on it. With that, you should have three threads. I don't have the exact same colors, but in your thread slide, you'll see one thread here, another thread here. Now let's pretend that you didn't just watch me draw that, okay? When you're looking at the microscope, you need to determine which one of those is on top. Well, you saw me draw it. You just saw me draw the red one last. But in the microscope, you don't really know which one is on top. So, but by looking at this, you can see the red is on top. You might be able to determine the black is underneath and the blue is on the bottom. But by looking on your threads and going in and out of it, you'll go ahead and you will illustrate the depth of a slide, because cells are not in 3D. Cells are not in 2D, they are in 3D. And so you're going to be able to look at a cell. If you can imagine this box is a cell. It's microscopic, it's a cell. So when you look at it, I would look at one cell surface, then I might look inside and see what's inside, then I would go past it and look beyond. And so imagine that's what you're doing with your cell specimens. So just answer the questions accordingly. Because all of our microscopes do not have ocular rulers, we are going to skip the part of the measuring of the cell size. So that is on page 9. Go ahead and X that out. I'm not going to revamp these documents. I'm just letting you know. X out that part with the cell size, which means you do not answer the questions having to do with that on the following page. Answer questions having to do with other things, but there is a small subset of questions having to do with the cell size on page 10. So pick up in the middle of page 10, and that is your dissecting microscope. Just do the same thing with your letter E on your dissecting microscope, and go ahead and answer the questions. Moving on to page 11, you're going to fill out the tables regarding dissecting microscope and compound microscope. Because we are taking out some stuff, I think you'll have plenty of time to work with your dissecting microscope. Please follow with filling out the conclusions that are on page 12. And that is your microscope lab. I hope you guys have a good time.